Thank you for inviting me today. I should maybe say that I have a background as an analytical chemist and advisor at the National Food Institute of Denmark, where I worked for 15 years on food contact materials. But in my new position here at the European Environment Agency, I work on chemicals, environment, and human health. And for those who are not familiar with what the EEA does, I would just give you a very short background. We're an agency of the European Commission, and we collect information from 33 countries, including the 28, maybe to become 27 member states of the European Union. We collect information, we assess it, we also evaluate what it means in terms of the state of the environment. We assess policies, how well are they implemented, and how effective are they. And kind of the main product that we deliver is, we are supposed to deliver, is state and outlook of the environment. We do this every 5 years, and the last one was published in 2015. And this gives trends for future developments in Europe. So which policy framework do we work in? Well, we work within the 7th Environmental Action Program. And as you can see, let me see, does it work here? Yes. As you can see here, it's highlighted that we would like to work towards a circular economy, in an innovative economy, where nothing is wasted and we do not degrade the natural resources, and we maintain ecosystem resilience. The question is then, how do we do that? And also, in 2015, the European Commission came out with this the circular economy package, giving a roadmap for how to achieve this. And quite interesting, that sets a recycling target of 65% of municipal waste should be recycled in 2030, and packaging is a very important component of that. However, at the same time, we also have, in the 7th EAP, it's said that we should have a strategy for a non-toxic environment by 2018, and it highlights 7 topics. One of them being the safety of children and vulnerable groups, and a number of other initiatives. It also highlights chemicals in products and non-toxic material cycles. So the question is, how can we then achieve these 2 goals at the same time? Because as it has been said by previous speakers, if we recycle things, we might get chemicals into the products that we do not know what are, that are not assessed, and if we want to recycle it over time, we might actually, in the future, find out that some chemicals were hazardous that we were not aware of to begin with. So how do we make these 2 goals meet each other? And what I've showed here at the side is that we, in 2016, at the EEA, came out with a report kind of framing the issues of circular economy. In this report, we also focus on human health and environmental well-being, human environmental health and well-being. And then, of course, there's the late lessons from early warnings, where it focuses on emerging contaminants. And all that, how do we deal with all the things that we still do not know? How can we try and manage that risk? So, to give a little bit more of a background of like, how is the overall picture for all of this? Well, chemicals in the circular and green economy, you can say that we have had some policies that focus on waste management, waste prevention, resource efficiency. I cannot do it over there. And the circular economy focus are these 3 parts, whereas the green economy focus actually also includes ecosystem resilience and human well-being. Ecosystem resilience would, for instance, include planetary boundaries. It would also include environmental health and human well-being. Do we have a happy life? Do we still have forests we can go and travel to? And will our children actually be healthy in the future? These are things that it's difficult to measure, but it is important for people, you know. As Amy also said, you know, mothers would like to have their children to be more healthy, you know, and not have diseases. So this is part of human well-being. Can we walk down by the sea and not looking at plastic litter? Is another thing that is included in the human well-being component. And chemicals are important components across all these systems. So in the circular economy report, it was highlighted some general aspects of circular economy. How do you enable a transition to a circular economy? What I've highlighted in red here are the components that I think are important for chemicals, particularly in food contact materials. There's something about the eco-design. How do we design it for a longer life, so the cycles we have will last for a longer time. Also that the time that the material is actually being used, regardless of the number of cycles, is long enough, so we don't discard the material. We also have substitution of hazardous substances in products and processes, etc., etc. Economic incentives and finances are also important components. So this is something you can look more into in the report. And some other factors that have been mentioned is eco-innovation. Here we have the technological innovation. We have also organizational innovation, that we communicate with each other, that we can transfer information along the supply chain, etc. And this is also part of the collaboration here and transparency. And finally, governance, skills and knowledge. It has been said, awareness raising, make people care. Because in the end, if you want action to happen, some people have to decide to do something about it. It won't happen by itself. So you need to activate people to make it happen. And there are various ways of doing this, and I really appreciate your talk, Amy, as well, because you said, well, what do people care about? It's really what's close to themselves, you know, their values, and something about your own health, your children's health is really essential. And it feels like a responsibility you have to actually live up to. And also education, which was mentioned before, is a key point, as well as data monitoring and indicators. And these parts, I think, is very important if we think about the non-toxic environment strategy. We can see how in the circular economy, having 65% targets for recycling really has moved it, you know, like there's a strong pull, you can say, or push to recycle. And to a point where we start seeing problems with the materials being of a quality that makes them difficult to recycle. So, if we want to achieve some consideration of the quality of the material, we might also have to set goals for the non-toxicity of the materials. So, looking more specifically into food contact materials in the circular economy, again, this is, you can say this is the circularity. We have some production of materials, starting here, and then we produce it, it is manufactured, it gets out to the consumer, and then we recycle it. And basically what we would like to achieve is to have materials go for as long time as possible in this circle, I mean to slow the circle, and we also want the circle to kind of continue over and over again. And we want to minimize the input of resources, and also to minimize the loss of resources. So, circular chemicals in food contact materials are of relevance because if you have, let's say, chemicals of concern, and by concern I mean actually chemicals that could be hazardous, but also that we suspect could become hazardous in the future. If they're in the material, you might have to incinerate it or downgrade the material. But it could also be that you have chemicals that interfere with the functionality when you have recycled it and then you want to produce a new material. This will also create a loss. So food contact materials, as said before, they're often very complex materials, and some of the incentives of the environmental incentives have that to use less energy for transportation has actually pushed towards making the materials even more complex, low-weight, multi-layer glued materials that are very difficult to separate. And as I mentioned, the longevity of the materials and the cycles here for food contact materials, it's also important to distinguish between single-use and repeated-use food contact materials. which could be considered. And also because every time you start a new circle over, it requires information and energy to actually start the circle again. So, as also was said by Michel de Smet from Ellen MacArthur Foundation, how well are these food contact materials captured in the waste stream is a question. So I will just very briefly go through a project that we have right now where we are trying to figure out which chemicals are tracked in the circular economy. Just a picture, snapshot picture. We have interviewed businesses and gone through a lot of materials. And we have found there that actually the main motivation for tracking chemicals is to be compliant with legislation. And that can be either legislation on articles, such as food contact materials, or manufacturing, so workplace safety, or waste. And to some extent also protection of brand, but this actually plays less of a role than we thought. Methods. Test methods are analytical testing. It's also supplementary documentation of compliance. But one of the main things is that since there's so many chemicals, you cannot test everything. You have to prioritize it. So what do companies do? They go out and test specific substances that are listed in specific legislations. They only test those that are most hazardous. And furthermore, they decide what is the likelihood of this chemical to be present or not, because they cannot test everything. And this is very important because it means that a challenge for testing recycled materials is if you don't know what's in there, how do you know how to prioritize what to test? And this seems to be actually a barrier. Also a barrier it is to actually communicate the information of very complex materials and substances with CAS numbers that nobody can pronounce is another. Because in this circular economy circle, you see you have many different operators and everybody are not chemists. So you want that information to be conveyed very precisely around and information not to be lost. So some of the solutions is to use, that companies have started to use, is to use procurement standards of groups of chemicals of concern, and it's also to use virgin materials. And I'm afraid that I have a little bit more, if I'm allowed.
1 minute.
Okay, 1 minute. Okay, so, yeah. One point is that in each cycle, if you have an increasing risk of migration potential of recycled materials, because you both have what was in there before, every processing creates new chemicals, and you also have addition of new additives, and sometimes you have compatibilizers to make different polymers. And this I will not go too much through, but again, risk is, as Jane said, is a combination of hazard and exposure. So if you want to create a non-toxic environment, you want to control the exposure to all these different sources. And that means if you want to control the risk, you can either decrease the hazard or the exposure or a combination. But it also means that you might need to have an integrated risk assessment to avoid burden shifting between these different areas of exposure. And one of the solutions might be to shift to less hazardous substances. So in conclusion, compliance with specific legislation is some of the ways that you can achieve, that companies nowadays see as a way to achieve quality of their materials. But burden shifting between environment and health is an issue. And therefore, we might need to have a kind of a development of an integrated way to assess both human and environmental risk assessment as well as life cycle analysis. And finally, we can see that this transition to a circular and non-toxic environment actually creates opportunities for businesses, because if you have to reinvent things to make them more recyclable, why not make them non-toxic at the same time? And so every time there's a change of a system, there's an opportunity to do things better. Many of the things have been mentioned before, and I think I would just end up by saying that really it gets down to getting people on board. So communicate in a way that people care. And with that, I would like to thank you.
Xenia.